Hi, 10th grade. This video is to walk you through our lesson for today. What we're going to do is be in Desmos and look at what is the volume of a sphere. First, I'd like you to share how your energy level has been over the last weeks and let me know how you're doing. So for me, definitely when I was sick with COVID, this low energy. And then it started getting better. I started to feel a little sick last couple days, kind of flattened out, but I'm better. Here we are. Keep moving. Take a look here and share what you notice and what you wonder in this GIF. Our goal today is to look at how cones, cylinders, and spheres relate to each other. And in doing this, we'll create a formula for the volume of a sphere and use it to find the volume of a sphere and a hemisphere. First, share what you notice these two objects have in common. One is a cone and one is a cylinder. On this slide, explore the relationship between the radius of the sphere, really the circle, and the height of the cone, and share what you notice. Then here, I want you to select the ones that are correct. What do they have in common and which is true? What you should have noticed is that they have an equal radius. All the radii are the same. And the height is 2 times the radius. And we get that 2 radius from the sphere because there's a radius going from the center of the sphere to the top and from the center to the bottom. Please watch this video to see how the sphere relates to the cylinder. And remember that 3 cones fill a cylinder. After watching that video, you should have seen that the cylinder and the sphere have the same height. And so we are going to use that to find the volume of a sphere. What we look at is 2 out of 3 parts of that cylinder. That is the sphere. Then we plug in the height of that cylinder, which is 2 radii. 2 of the radius add up to that full height. Then when we multiply that 2 times 2/3, that's where the 4/3 comes in. And notice we have r to the 2nd power times another r in parentheses, and that equals r to the 3rd power. So here's the final formula for the volume of a sphere. When you scroll down, you should see the center of the sphere and the radius going in multiple directions. There's an infinite number of radii going out from the center of this sphere. But the height of that sphere and the height of that cylinder is 2 radius. Here are all the formulas for prisms, cylinders, pyramids, cones, and the sphere. Now consider a hemisphere. I encourage you to draw one. I always draw a curve and then draw an oval on the top and then indicate where the center is. And there is your hemisphere. I'm trying to change the color. Here's your radius. Now, in order to get the volume of a hemisphere, we just divide the volume of a sphere by half. I would like you to pay attention to how I'm typing these symbols. Notice I'm typing math. Volume equals 1 divided by 2, because we're going to have to take half of the sphere, and that's times shift 8, look for the asterisk, is multiplication. And you can also click on the keyboard when you're not in full screen. And that keyboard allows you to multiply. Notice that asterisk. Okay, but then we also need the 4 divided by 3, and then we need pi. Remember, type pi in lowercase, and the symbol pi will come up. And then we have our radius, shift 6. Look for the little caret. That brings up the exponent, the power of 3. Now, when we simplify this, what's 1 times 4? What's 2 times 3? Well, that is equal to 4 divided by 6 times pi times the radius cubed. Now, you do not need to go through this as you are working in Desmos, but I want to make sure you see how this is developed. But now 4/6 can be simplified even further. So 2/3 times pi times the radius cubed is the volume of a hemisphere. 2 out of 3, where the sphere is 4 out of 3. Let's put these formulas to use. So this first one, the radius is 13. So we take 13 to the 3rd power, and then times pi, and then times 4 divided by 3. And notice that's 2 decimal places, and submit. Excellent, we figured it out. I'm going to show you one other practice using a hemisphere. Notice this hemisphere has a diameter of 5. And so that means our radius is 2.5. So we take 2.5 raised to the 3rd power times pi times 4 divided by 3 times 1/2. Or notice that we could just go back here and do 2/3. And we figured it out. Challenge yourself to work through all of these practices, do the card sort, and then let me know how confident you're feeling with spheres and hemispheres. Thank you for watching the video. Come see me during office hours, during our regular scheduled time if you have questions.